all for your AP Chemistry review packet. This is the packet you got on Monday. I'm going to do number 4 on the first page, the Hess's Law page. So the question number 4 says, calculate the standard enthalpy of formation of cyclohexanol, C6H11OH, given the following standard enthalpies of combustion in kilojoules per mole. And then the enthalpies of combustion are given. So this question has a ton of information in it. The first thing we need to do is write the information out. And if you write it out, you're going to have a much better chance of getting the question right on the first try, and it feels good. So I'm calculating the standard enthalpy of formation. So I'm going to be forming 1 mole of cyclohexane, C6H11OH. And in formation, I know that I have to form it from its elements. So I see I've got carbon, hydrogen, and oxygen as they exist in their standard state under standard conditions. So that's, I'm going to have carbon as a solid. Shouldn't balance yet, it's a little weird. I have hydrogen. Hydrogen exists as H2 gas in its standard state. And oxygen exists as O2 gas in its standard state. And now we'll go ahead and balance the equation. I've got 1 oxygen, so that's 1/2 of an O2. I have 12 hydrogens, so that's going to be 6 H2s. And I have 6 carbons, so that's why I put that. So the goal is, how much heat is coming out or being absorbed during this reaction? When 6 moles of carbon react with 6 moles of hydrogen, 1/2 mole of oxygen, and they make 1 mole of the cyclohexanol. So I have all of these enthalpies of combustion. I'm going to write out what they mean down here to leave myself some space right below my goal, and that way I can flip the steps around. So the first one I have, I've got combustion of the cyclohexanol. So combustion is reaction with oxygen. And when I have a hydrocarbon, carbon and hydrogen, and I react it with oxygen, I combust it, I'm always going to make water and carbon dioxide. Let's go ahead and balance that. There's 6 carbons, 12 hydrogens. Now I have 6 O2s. 6 more, so it's like having 9 O2s, but I've got 1/2 of an O2 right here. I have 1 O, so this will be 8.5 O2s will balance my oxygens. And I'm given the change of enthalpy for that reaction. It's a negative 3,727. I also have the combustion of carbon. So again, combustion is something plus oxygen. In this case, the synthesis reaction, also combustion, is going to be CO2. And the enthalpy for that reaction is given 393.5 kilojoules per mole. And I also have combustion of hydrogen. So that's hydrogen plus oxygen. Again, it's 2 elements, so it is a combustion. It's reacting with oxygen. It's also classified as a synthesis, so I just put them together and balance their charges, H2O. And I have the change of enthalpy, negative 285.5 kilojoules per mole. So now I have the steps. I'm going to flip these steps around, multiply them, do whatever I need them to do to get them to add up to my goal equation. And I can see how much heat is coming out every time I do one of those steps. And then I can add up all the heats to get the overall heat of the reaction. So for the first step, I know that I need cyclohexanol as a product. The only place it shows up in the reaction is right here. It shows up as a reactant, so I'm going to flip the first step. So that means I'm actually going to take the 6 waters, reacting with the 6 carbon dioxides to make 1 cyclohexanol, and those 8.5 waters. And I have the enthalpy for that reaction. Since I flipped that step, this is now positive. So positive 3,727. The next thing I see is I have 6 carbons in my goal, and the only place carbon shows up is in the second step. I'm going to do the second step 6 times. So I'll take 6 carbons, okay, so 6 carbons plus 6 O2s, I'm just going to multiply the whole thing by 6 to make 6 CO2s. Since I did this step 6 times, I'm going to multiply the change of enthalpy by 6 because I did it 6 times. So negative 393.5 kilojoules per mole. Then I also see that I need 6 hydrogens, and I can get them from this step. I'll do this step 6 times. So 6 H2 plus 3 O2s will give me 6 waters. And the change of enthalpy will be 6 times what it is for doing the reaction once, so negative 285.5 kilojoules per mole. Okay, so hopefully these steps are going to add up to the overall reaction, and hopefully my oxygens will be taken care of. I couldn't look at any one step to figure out what to do with that step based on the oxygen, because it shows up in every step. So I'm hoping my steps are going to add up and cancel out the oxygen since I have everything else. So let's go ahead and total the steps to make sure I actually did hit my goal. Oh, and first I get to cancel stuff out. So yay! 6 waters, 6 waters, 6 carbon dioxides on either side, 8.5. Ooh, I wrote water there, but it really was oxygen if you remember. I think I even said oxygen as I wrote it, but sometimes my hand and my mouth don't agree. So 8.5 oxygens. I've got 9 oxygens on this side, so all 8.5 are going to cancel, and this will end up being just 1/2. So 1/2, and then this is gone. Okay, so that does add up, because I'm left with 6 moles of carbon, 6 moles of hydrogen, reacting to form, plus 1/2 oxygen, right? React to form 1 mole of cyclohexanol. Okay, since these steps react to give me the overall reaction, I can say during the first step, I absorbed 3,727 kilojoules. And then during the second step, I gave off 6 times this 393.5 kilojoules. And during the third step, I gave off 6 times this 285.5 kilojoules. And overall, since these 3 steps add up to the goal, then these 3 changes of enthalpies will add up to the change of enthalpy of the goal. And that's how you'll get, you do it, negative 347